Hello everyone, welcome back to VLSI for All. I'm Neeraj Chariala, back with yet another interview. And this time we have Kshema Parak joining us. She has got a very rich experience in DFT domain. She is currently working as a senior lead DFT engineer at NXP. Before joining NXP, she worked as staff engineer at Samsung and as a DFT engineer at Intel Corporation. She has got an MTech degree in VLSI from Nirma University, Ahmedabad, and has also a BTech degree in ECE from Bhilai Institute of Technology, Raidurg. So I take all the pleasure in welcoming Kshema Parak to our channel. Thank you, Kshema, for joining us tonight. We are very glad to have you with us.
Thanks, Neeraj. Thanks for inviting me for this. And I'm really glad that I'm here. And with this talk, we will be able to help the upcoming VLSI aspirants. Thanks for welcoming me.
Yeah, thank you so much. So, although I've introduced about your career a bit, we want to hear it from you. So, could you please introduce yourself to our audience?
So I'll introduce with the meaning of my name. So it's Kshama. And throughout, I have listened it as Kshama, Kashma, and so on. So I would like to start with the meaning of name, which is forgive, so that everyone can pronounce it properly. That is Kshama. And there's a story behind my name that I will share if time permits. So starting with that, I have done my BTech from Bhilai Institute of Technology. Though the name says Bhilai, but it is located in Durg. It's a town in the state of Chhattisgarh, and it's a very good college. Then I did my master's from Nirma University. As a part of second year master's, I joined Intel as an intern. And then I continued there for 4 long years. And then I moved to Samsung, and finally here I am in NXP. So that's all about my professional journey and little bit about meaning of my name.
Yeah, we can get back to your name later on in the interview. So, how has been your experience with NXP working as a senior lead DFT engineer? I guess it is around 4 months right now for you.
Yes.
Okay.
Yes.
Yeah.
So I have joined NXP on 3rd March 2022. It's been almost 4 months. So far, it's very good because all this while, the moment I have started my journey in VLSI, I have done all my work in MBIST, which is memory built-in self-test and on memories. But in NXP, I have got an opportunity to work on scan and ATPG, which is nothing but a way to test logic in your design. So as of now, it's whole new experience. I'm learning, I'm trying to explore and grow as much as possible. So far, so good. Long story short, that is what I can say.
Yeah, so since you have mentioned about some of these architectures, like, I mean, could you just explain our audience about these DFT architectures a bit more?
Yeah, sure. So if you will take any SoC chip, right, the chip typically contains of 2 parts. One is memory part, which stores everything. One is the logic part, the actual logic implementation, which will do the functionality for you. For example, if you're building a calculator, which has to do a function of 2 plus 2, that will do 2 plus 2, and it should give a result 4. So that structure needs to be tested after fabrication. So that is what is called logic testing. But if you see memories are a bit different in architecture. Structurally, they are arranged in arrays and they are very tightly packed. So in order to test them, we have a different fault models and a different way of testing them with different algorithms. So that's called memory testing, which in short form we call MBIST, memory built-in self-test. And for logic, you can tell scan or logic testing. It's just scanning through the entire logic structure. It's all after fabrication. Once your chip is fabricated, you'll try to test it through this logic, which we will introduce at the front end during the front end designing. So you can broadly classify into memory and logic.
Okay, So I got some of the, I got the gist of what DFT does.
Mhm.
So how does this influence the work of a designer at the logic level or the work of a designer at the backend level? Is there any influence of DFT on these workers,
So
these engineers?
I so what I would say is DFT is more of an interdisciplinary domain. You have to have a very clear understanding of cross domains. For example, you receive an RTL. You have to make sure that your RTL is compatible in such a way that you can implement the DFT logic. It should not break the functionality when you are putting your DFT logic. So if it is breaking something, and if your LEC is equivalence checking. You just check your design whether it is logically equivalent or not after doing something and before doing something. So you have to check it. If it is failing, then you have to find out why it is failing. You have to give the feedback to the designer. He or she will analyze it, fix it, give it back to you, and you will again do those checks. Those checks comes under spyglass DFT. It's like spying the RTL. You are literally spying on the RTL which you have received from the designers, not with the intent of blaming them, but in the intent of getting a good quality product which you can ship to the customers in order to gain their trust or maintain their trust. So that's why we do the DFT, in order to make sure your products are reliable enough.
So the answer which you just gave, it also gives us a sense about what role that does DFT exactly play in any design. So it's
Mhm.
a significant role, as I can understand from your answer, in the whole design cycle.
Yes. And this is the one part, giving feedback to the RTL designers. The next part comes getting feedback from the backend team. So you have taken the netlist, or once synthesis is done, you take it, you do your scan insertion. The moment you give it back to the backend team, they may see some violations because you have introduced extra logic as a part of DFT. Take the feedback from them, analyze it, fix it, and give it back to them so that we are not breaking the functionality, because that's the actual intent of building any chip. If you're building a calculator and 2 plus 2 is giving 3, then whole intent is failed. So in DFT, we make sure we are adding some circuitry which makes it testable after it is manufactured or fabricated, while making sure the functionality is intact. So that's a whole about DFT, you can say.
So after the fabrication, you said that we will test the chips after fabrication. So
Mhm.
what teams you usually involve in that testing after manufacturing?
I would say that comes under silicon validation team or silicon testing team. So because we are front end DFT engineers or DFT designers, we are the ones who will implement everything during the front end process. And those hardwares which we have already introduced will help silicon validation engineers to test it. Do we have any fabrication defects? Do something went wrong while fabrication is happening? You might know extra doping concentration, uh, the mask, and many things are involved. Fabrication is again a huge process and a huge domain to understand, but it's definitely not an error-free process. So we have to make sure that we don't deliver anything which is defective to the customers, which will ultimately impact the trust which we have on us as a company. So that's why we have to do the DFT.
Yeah, so we completely understood what DFT does in the design cycle.
Yes.
Thanks for that. And
Mhm.
respect to the NXP thing, like what are some of the projects that you are working under for NXP? I mean, what are the products that you
Mhm.
are DFT for? You
So
can
see,
just give
for
us.
NXP, yeah. So if you will see, right, NXP is mostly does automotive projects where the most important thing is functional safety. You have to make sure that your chip is functionally safe when it is in the field. For example, you have designed a sensor or an infotainment chip, which is there in your car, or if it is airbags, which have to come out as soon as it hits some obstacle. So you have to make sure that it is tested and it is defect free while doing the DFT in front end or back end, because it may cost a life if it is not tested properly. So that is the whole intent. And it does have many projects in other domains also, like healthcare and other domains. But I have started with automotive projects, and that's where I'm working on.
Yeah, got it. So how easy was it for you to transition from Intel to Samsung and then to NXP? You had two transitions in your career.
So for this question, I would be honest, when I was 2 to 3 years of experience in my VLSI journey, it was a bit difficult for me because at that time I didn't have the deep knowledge. It was a little bit superficial. And that's where I felt trapped in the interviews for the follow up questions. Because you can answer follow up questions only when you have a crystal clear understanding of the entire process or concept. But as and when I started understanding things clearly, the DFT concepts, the functional verification concepts, everything, eventually and gradually, transitioning becomes easy. And with that process, I started gaining a clear mindset of what I want and where exactly I look myself after, say, 10 years or 5 years. And then it becomes easy. So that's how it is for me when I planned a transition.
Yeah, so you're saying that if we are crystal clear with the concepts in depth,
Yes.
for example, let's say with respect to DFT, so it would
Mhm.
be easy for us to get into any other company.
Yes, that is what I would say. And you have to be very clear about the job description, which they have mentioned. So be clear that this is the job description which they have mentioned, and this is the right skill sets which you have. It should be properly aligned. There should not be a misalignment, because once you are into the job, the expectation is different. You are expecting something different from the company. That's where you again start thinking of a transition. Transitioning is not a bad thing, but it should be in a balanced way. That is what I think from all this experience.
Yeah. So can we take these things as suggestions whenever we try to switch companies within our domain?
Sure. So I have few points which I thought. First of all, is like what exactly you are looking. For example, in DFT, do you want to be an MBIST expert or you want to be a complete DFT expert? So look for such role. For an instance, if you will see my profile, from last 6 years or 5.5 years, I have worked only on MBIST. If you will see my resume, it's all MBIST. And I was very clear that I wanted to continue to work with MBIST, but I also want to learn scan and ATPG concepts, which are very necessary to do logic testing. And that's how you can envision yourself as a DFT lead or a DFT person. If you say I'm a DFT engineer, you have to have that breadth as well as that depth also. So initial years, because I was exploring, I was learning, I used to take everything, whatever was assigned to me. And then eventually I was a bit clear that this is what my path will be. So you have to be clear what you want and then how you want to achieve it. The second thing which I feel is the company culture and the environment of the company. First of all, you have to understand in which environment you want to work. Like you want a very stringent working environment because you are workaholic and you like to work for so and so many hours, well and good. You can go ahead and choose the company. If you want little bit relaxed, like you want to work also, you want to enjoy little things, then choose accordingly. So first understand which kind of person you are, explore, get the feedback from your network. Please build a network. I'm not saying a huge network or small network, but the network which can give you a good feedback. Okay, this is how this company works. You can go ahead and give the interview. So that honest feedback you should get. So I'll always do before joining a company, I'll go ping few peoples in the LinkedIn, explain them, this is what I'm looking for. Do you think, is this a good choice for me? Accordingly, based on my research, based on their feedback, I'll decide. And then last but not the least, the compensation which you are looking for. Definitely, that also you should consider. So yeah, that's what I would say from my experience.
Yeah, cool. So those were very good suggestions. I guess audience would take them whenever they're planning to switch. And I mean, as you've got a good experience in VLSI domain and you are somewhat senior, so like how easy for it for any candidates to switch from any other domain to VLSI domain? And like what
Mhm.
would they encounter when they try to do so? For example, any guy
So
from better domain wants to switch into VLSI.
mhm, I think if you have, I would say, where there is a will, there is a way. That is what I can say. Because I have seen many of my colleagues, few colleagues were in the graphics domain, they were graphic designer. But then they started seeing the growth in the VLSI industry. You say that industrial boom in that industry. And then they slowly started getting trainings. So there are many trainings institutes. Personally, I have not taken any trainings from those institutes, but I have heard from my colleagues who have shifted from one domain to another domain. And it's not like they will fully train you, but they will give you some glimpses. Taking that, you put your own hard work, and then definitely you can transition it. Definitely, it will require your time, patience, hard work, but it's doable because I have witnessed such colleagues and they are doing really, really good in the DFT domain. So that is what I can say.
Yeah. So you have talked about DFT for digital design, right? Till now, the architectures which you
Mhm,
have talked about. Is there any
mhm.
separate DFT architecture or sort of architectures for analog design? Is there any design
Yes,
for testability for analog designs as well?
yes, we do have. If you will see, one is DFT for digital, the another domain is AMS, which is called analog and mixed signal DFT. And though I don't work in that domain, but there is a team which heavily works in that domain to make sure analog part of the design is being tested with some technology, with some technique or methodology which they have developed. Each company will have their own methodology, and accordingly they will do it, because a design can never be completed without an analog module. So you have to test it and make sure. But yeah, that's a different domain, though I'm not exposed much on that domain. So I cannot comment much. But yes, DFT digital, DFT analog, we have both the domains. So someone who is looking to work into analog domain, they can explore further.
Yeah, just had that doubt if
Yeah,
it's also available
it's
for
there.
an. Okay.
Yes.
So what were the projects that you have handled as DFT engineer at Intel? You have talked about NXP, right? Similarly, what
Yes.
were the products or the projects that you were involved at
Mhm.
Intel and also Samsung DFT domain?
So Intel, I will start with my internship project, which was my not so favorite, but it has given me huge exposure, you can say, about many things. So you can say the CAD part of it, the automation part of it. I was introduced with UPF, which is Unified Power Format, which is basically for your low power designs. So title the title of my project was Impact of UPF on DFT. When a design which already has DFT, and then you have to make sure that your design is a low power design. That's where you have to write a UPF code, which is UPF, Unified Power Format. Previously, it was called as Common Power Format. So you have to make sure you will write a power state table Similarly, the way our laptop works, right? Shutdown mode, hibernate mode, and on mode. Similarly, you have to define and accordingly your design will work. That was my first. And subsequently, there are many projects. One, if you will see Lakefield, if you'll go and search on the web, that was the project which I have worked on. It was a very innovative project. They have done innovations. And that was the project where I have started working on MBIST. So many challenges were there, but I slowly and gradually, when I look back, trace back, I can relate back everything. So then I have worked on modern projects, which Intel does. And then they have slowly adopting it to non-Intel architecture products. Because all these projects which I have discussed are based on Intel architecture, the architecture which Intel will define for their own foundry. But if it has to go to some outside foundry, they have to follow a standard architecture. So few of the non-IA projects and some of the test chips. We usually do test chips in order to make sure the product which we are designing will come out clean. For example, if you have a fully integrated voltage regulator in your chip, the product, you have to make sure that it is working standalone. For that, you have to design a test chip. It's basically a proof of concept. You have to do a proof of concept before taking it to the product. So few of those chips I have worked on.
And what about Samsung?
So in Samsung, I was there for around 14 months. So there I have worked on ARM cores, and there the MBIST was done. For ARM cores, it's a different architecture which we use, which is called shared bus architecture. So if you'll go and search, you will get many documents. Why shared bus? How exactly shared bus is done? And it's not just you can do it only for ARM cores, but ARM has given you a standard interface. This is the interface, and you have to communicate only through this interface. You cannot go ahead and put anything, whatever you want in the design. No, that's not allowed. You can put, but you have to communicate with that interface, which is called shared bus architecture. So Samsung, I have worked mostly on that particular architecture and more of a timing simulations, GLS.
So since you have, you might have given interviews, right, for Samsung and Intel before joining them. So what are all the suggestions that you can give related to DFT interviews for Intel or Samsung or any other company? In that case?
So I would say, so in interviews, the common things which will happen is even if you don't know, you'll try to answer it. And the moment you try to answer it, you are trapped because you'll get a follow-up questions. So I would say, be honest. Okay, in first interview, you are asked 10 questions, 8 were wrong. I know it doesn't feel good, but it's okay. Come back, revisit those 8 questions. You don't have to find the answers. You think, you try to correlate to your current work. You try to understand the concepts. Go back again. Reappear for interview. This time, maybe you will give 6 right questions out of 10. Revisit those 4. And this was the technique which I used to follow, which helped me to grow my concepts as well. So I would say, don't fake it. That's what I would say. Because the interviewer knows everything. Though they doesn't tell you, they will not show you, but they know everything. So it's better not to fake it.
Okay, just out of
Just try.
curiosity, you taken
Yeah,
any
yeah.
interviews for candidates?
I think I have taken one, and it was good. It was only once I have taken. But yeah, I didn't get an opportunity to interview many people.
Okay.
Yeah. But even I can sense if someone is faking, I can make it.
Yeah, got it.
Yeah.
You mentioned these terms like Tessent and logic vision. Could you please talk more about them?
See, Logic Vision was a company long back, which was acquired by Mentor Graphics. So when Logic Vision was a company, they have their flow, which is called LV flow. And I have used that flow to do MBIST insertion and validation. So if you have a design, there will be a CAD tool which you will use. Because these MBIST logic which we will insert, right, they are third-party IPs which we will put if you don't have an in-house solution. Some companies, they have the in-house solution also. So there you don't have to use. But Intel and other companies, if they're using LVision, then you have to adopt. After that, because LVision was not that popular and it had some problems, or you can say the improved version has come, which is Tessent. So Tessent gives you a flexible and simple architecture of doing MBIST insertion and validation. And the most important thing is, if you're doing it at the block level, you can retarget it to the top level. Like you can kind of reuse it. So that was the advantage which was given with Tessent tool. So as of now, if you will see, whatever company, if it uses third party, they will use Tessent. And there's a concept called ICL and PDL. ICL is interconnect connectivity language, and PDL is programming language through which you can sum up your entire design. And again, if you're at the top level, if you're using the same tool, you don't have to rerun for the sub blocks. You can just read those and create at the top level. So it's more flexible. That's why companies have shifted to Tessent.
Yeah, got it. So that was very knowledgeable, the things which you were talking.
Yeah, I think if you'll see Tessent, right, you can get many documents or many content over the web.
Okay.
Tessent and this, if you see. I am not sure with LVision you will get or not, but Tessent you can get many videos.
This seems very interesting, especially for those candidates who are looking to enter DFT domain at least. This is very interesting.
DFT is very interesting.
So, Kshema, you have also included this CDF from inside in your profile. You have mentioned it under your education. So, could you please tell us what does this mean? CDF from inside.
Yeah, sure. So, not in between, recently also, if you will see, there is much talk about artificial intelligence, machine learning, and it's still going on. So I was very curious, like how it can help in DFT or specifically in VLSI. So I came across this INSEAD, which is International Institute for Artificial Intelligence and Data Science. I joined that institute. It was all online coaching. I think it was for 3 months every weekend. It was weekend classes. And CDS stands for Certificate in Data Science and Foundation. So it is a foundation course which will help you understand what exactly data science is, what we do in data science, and little bit of Python, because Python is the programming language which you can use for data science, like data mining. So it was a short course. I have taken it, but unfortunately, I didn't get a chance to implement something in DFT domain. But it was a good course which I have taken from INSEAD, that institute. So that's all about. They have many advanced courses also. If you're interested to build your career into data science, I would say it's very good. If you put all your effort and time in there, you can be a good data scientist. That is what the need of the hour, along with VLSI.
So, I mean, do you see any scope for ML or data science in DFT? Although you said you were unfortunately not able to implement it.
Yes.
How do you see the scope of ML in DFT?
I think there is a scope, but then the thing is you have to understand it properly, and then you should be able to connect it. And I think it will be helpful in the automation, like maybe automating the testing process, which we do once the silicon comes. So it's like you have to sit and brainstorm. You have to read the work which is already done. You have to go through some papers, which I have not done. But yeah, there should be a scope which we can leverage from machine learning and artificial intelligence and use it in not only in DFT, but as a VLSI whole.
Yeah. So coming to your college days now. So
Mhm.
how was your experience at Bhilai? Yeah, Bhilai is a good college indeed, and also at Nirma
Yeah.
University. Could you please talk
Yes.
about any of your memorable experiences?
So I will start with my BTech college, which is BIT. So don't confuse it with Birla Institute of Technology. It's not that. It is Bhilai Institute of Technology. Though the fun fact is it is not in Bhilai. It is situated in Durg. And Durg is a town in Chhattisgarh. It's quite good. So it's one of the most prestigious and well-established college, I would say private institution in Chhattisgarh. And you have a PT test which you have to appear. Based on that ranking, you can choose your branch in that college. So it was a good college. The faculties were good. The lab exposures were good. The course structure was good. So I did my bachelor's from electronics and telecommunication branch, and overall it was a good experience there. And one fun fact, or the point where it stuck, that okay, I want to go to VLSI, is my seventh semester, where I have learned about stick diagrams. They will have a colorful diagram which will show you the logic connection from your actual logic to the power and ground. So it was very fascinating for me. And that's where I decided I have not thought about any job, anything. At that time, DFT for me was discrete Fourier transform. It was not designed for testability. Oh, I forgot. I have not even told the full form of DFT, assuming that everyone will know. But freshers or VLSI aspirants, be aware if you go online and search DFT, don't ever think that it's a discrete Fourier transform. Yes, discrete Fourier transform we use in signal processing as far as I know. But please search DFT VLSI. That's where you will get design for testability. And that's what all I have talked about all this long. So, and then I thought I'll do masters in VLSI and C. And that's where I started my journey with Nirma University. Unaware of everything. I just wanted to study and know what VLSI is. I took admission, I started studying. To my good faith, or I was lucky, I came to know that second year was not a classroom. It's all industrial internship, which you have to do. So 1 year you have to be in classroom. You will read all the concepts, you will understand, you have to write all the exams, make sure your grades are good, your concepts are good. And then second year, different companies. I remember ST Microelectronics, Broadcom, Intel. These were the three companies which will visit for taking your interviews for internship. Once you clear it, you will get an internship in one of these companies. So I remember I appeared for Broadcom first, and it was heartbreaking for me. I don't know what I said. It's okay. They rejected me. I again prepared. I appeared for Intel and I was selected. And that's where my journey started in VLSI. I finished my internship. I started searching internally because unfortunately my team does not had openings at that point of time during internship. So you will do internship in one particular team. And my team was a CAD team. It used to develop flows and methodologies for the DFT backend. Once they will develop it, they will give it to you. You use it and do your DFT implementation. But I was not at all interested in coding at that point of time, and they don't have opening. So I didn't stop there. I created my network. I started searching internally. Every day I'll come, open my laptop, ping one or the other manager and ask them, if you have opening, I'm ready to come and give the interview. And I'll keep studying everything, all the domains. If it's RTL, okay, I'll appear for RTL. But finally, because I wanted to be in DFT, I landed up a DFT job in Intel. And I continued for 4 long years there. It was a good experience.
Yeah, that was quite an experience. So what were some of the projects, if you remember, that you have done as part of your MTech or BTech when you
So
were?
my MTech, so my MTech project which I have done, right, is same as the project which I have done during internship. We will do that project and present in our college, which is, as I mentioned, impact of UPF on DFT. Basically, once you introduce UPF in your design, your area, power, and performance will be impacted. And then you have to analyze and make sure that it's within the range of the specifications which you have got from the customers. And if you will ask me for BTech, yeah, we have done it. It was a group of 3 people, I and 2 of my classmates, and it is ultrasonic security system. It's basically a burglar alarm. If you have some thief and all, based on some microcontrollers, signals, and MATLAB scripts, it will send you a message that some intruder is there at the door. Please be aware. So at that point of time, we have done this project, implemented it, and then we have given a demo, and finally done with our thesis for the BTech.
Yeah, that was good. And since we all know that India's semiconductor mission is already in place, so how do you see the growth of VLSI industry in India in the coming 5 years, and also the job opportunities?
I think India is showing a tremendous growth, like it's displaying a tremendous growth in VLSI field. And I'm very happy to see that tech giants, you say any tech giants, they are setting up their R&D center here, because we as an Indians, uh, we show our interest, we give some results based on the research and development which do. And then our prime minister at the right time, I would say, he has launched this initiative, which is called ISM, India Semiconductor Mission. It will definitely, it will create huge number of jobs. But in some of the survey, I have read that it will create around 1.3 lakh of jobs in the coming years. Not exact, I don't know when exactly, which exactly those years are, but definitely it will create. And one more thing which I think is, though I think 76,000 crore is sanctioned for this ISM. That is very good, but we have to be very sure and very cautious, because if you will see a fabrication environment, it needs clean air, and clean air have different classes: class 1, class 10, class 100. So we have to make sure, considering the air quality, we have to make sure that it is very clean and we are able to do the manufacturing here. Otherwise, we can wait and then start. Because if you will see, for most of the tech giants, their manufacturing or fabrication unit is not here in India. It's either in US or in China, because it's a huge investment. So though the overall initiative is very good, it will definitely create lots and lots of job opportunities. But from the fabrication point of view, we still have to see how it goes.
So what do you think about VLSI for all and its initiatives?
So I'm very happy that I came across, or I should say, you came across my profile and you have given me this opportunity, because I have always believed in this fact, giving back to the community, because I have taken so many things from the community, whether it's my mentors, my network, anyone who is into VLSI helping me, telling me, discussing VLSI concepts. So I think VLSI for all is doing a fabulous job in guiding or showing a right path to the VLSI aspirants or freshers, or someone who wants to switch from one domain to VLSI domain but does not have a clear picture. So I would say this VLSI for all and its initiatives is completely aligned with my thought of giving back to the community. And I'm very happy that you guys came across my profile and I came across VLSI for all, and we are connected over LinkedIn. And I'm seeing for many more such collaborations so that we can help the community and give back what we have taken from this community. So all the best, and you guys are doing good work, helping everyone.
Yeah,
And
so
I'm glad that I'm here sharing my experience. I hope this may help.
yeah, definitely this will help all the aspirants who are watching this session. And we are
Mhm.
also very glad that you have accepted and you have given a very, this was very knowledgeable session regarding VLSI in general or specifically DFT and the experiences that a person in VLSI industry would have or the situations that he or she would go across. So this was quite a knowledgeable session. This is in fact uh, one of the most knowledgeable sessions that I had in my journey with VLSI for all. Thank you for all the knowledge that you have shared. And finally, any life motivation or suggestions that you would give to Kshema when you look back 5 years back when she was starting out her career in VLSI?
Yes, definitely. I have three suggestions, I will say. First of all, be confident, trust yourself. Second thing is be resilient. See, there will be setbacks in your professional life, setbacks in your personal life, but try to bounce back as soon as possible. Don't be there in the deep valley of deep thoughts or tension or depression. Try to come back as soon as possible and restart all over again. First is confident, be resilient, and be daring. It's okay. Today, if you don't know, you will learn. We humans are so adaptable that we can do anything, and we have done everything. If you will see, we can sail through water, we can go underground, we can fly in air, everywhere we are. The only thing which we cannot control is one day we all have to go, and that's okay. Everything we don't want to control. And one more thing, DFT, I will say, it's all about observability and controllability. Be a good observer and just try to control what you can control. Don't try to control everything. If once you enter into DFT field, there are many points and many nodes that are uncontrollable and you cannot do anything, and that's where you will lose your test coverage or fault coverage. You will know once you enter into the DFT field. I know it's being a little bit technical, but again, I would reiterate 3 points: be confident, be resilient, have some daring. I would not say all the time to play truth and dare, but have some daring and achieve what you want. Maybe it will take time. Be patient, and eventually you will be there. So, yes, this was the suggestions which I would have given myself 5 years back.
And indeed, the same suggestions you would give for any fresher starting out for her career in VLSI.
Some more like these are the things which I want to give it to myself, and I think this applies to everyone.
Yeah.
And one more which I will add: be patient, because I, as a person, I'm being little impatient with the things which I handle. But over the period of time, I have started developing patience, and it has helped me a lot. It will keep you calm, it will keep you cool, and then eventually you'll be able to finish whatever you have decided for yourself. So be patient along with resilient, confident.
Very interesting suggestions and indeed very interesting analogy, especially for those candidates who understand controllability and observability. Yeah. So
Yes, I think because if you will write DFT, right, 2 points will come: controllability and observability. So I would say observe everything, but don't try to control everything, because some things in life, your professional life, your personal life, will be uncontrollable, and let it be. It's okay. So that is what life is all about: controllability and observability. Come, start working into DFT. You will start embracing your life even more.
So I can end this session with 3 words, similar to your 3 suggestions. So this session was, first of all, quite knowledgeable, quite interesting, and then it was thought-provoking in many aspects. Thank you so much, Shema, for joining us tonight. And we are very glad that we had you with us for this session. And we are looking forward to collaboration in the future with you. Thank you so much.
Sure, sure. Same. Thanks for inviting me. I'm happy that I am a part of LinkedIn, and through LinkedIn, we are doing so many good things which are helping so many people out there. So thanks for inviting me. Thanks a lot, Neeraj.
Yeah. Thank you, Kshama. We'll be always grateful to you. And thank you, all the audience, for joining us and watching the session. We'll be back with yet another interview, many other interesting interviews in VLSI domain. So for today, this is it. And this is Neeraj Charyala signing off. Bye.